misinterpreted. All right, number 2 on the 2024 free response release date items from the AP calculus test. Particle moves along the x-axis, so its velocity at time t greater than or equals 0 is given by this function here. But v of t equals ln of t squared minus 4t plus 5 minus 0.2t. There's one time t equals t of g, I think that says g, no, t of r, sorry, in the interval from 0 to 2 when the particle is at rest, not moving. Find t of g. All right. So when your velocity is equal to 0, that's when it's not moving. So we're looking for, in the interval from 0 to 2, I'm going to set my x min at 0, my x max at 2. And I don't know what this is going to be a relatively small velocity, so I'm going to go ahead and change my y min and max to -10 to 10, just to see what happens. We may have to change that. Then I'm going to go ahead and put my y equals, I'm going to clear these functions from before, and put in there ln t squared. I'm going to use x instead of t, minus 4x plus 5, close parentheses, minus 0.2t, that's x, what we're using, and I'm going to graph that. And it tells us there's one time when the particle's at rest, and it's going to be right there where that intersects the x-axis. Just for illustrative purposes here, I'm going to change the window so you can see more clearly. I'm going to make this from -3. Oops, that's going to be 3. No. -3. The graph. Well, I don't know why I did that. I was supposed to do the y's is what I wanted to do. Go back again. That was my fault. Window. This was -10 to 10. No, 0 to 2, wasn't it? This is what I want to change from -3 to 3. Just so y'all can see more clearly where that intersects the x-axis. When the velocity is equal to 0, that means the particle is at rest. Even if it's only instantaneously, it's at rest right there. We're going to do second trace, 0, left bound, right bound. One of the 4 tested calculator skills on the AP calculus exam is that you can find the zeros of a function. So when t equals 1.425 or 1.426, t equals 1.425. That means that v of t equals 0, so the particle's at rest at t equals 1.425 seconds. What is seconds to tell us? It didn't give us. All right. Find the acceleration of the particle at time t equals 1.5. Show the setup for your calculations. All right. The acceleration is the derivative of velocity, so we're going to go dv dt when t equals 1.5. So that means we're going to take the derivative of the velocity. So we're going to set this up in a calculator. 1.5. This is another tested calculator skill. So we're going to do math. We're going to do n derivative. Whoops, dang it, I got to get out of this graph window again. Math, n derivative. And we're going to take the derivative with respect to x because that's to have it entered in the calculator. And we're going to do the y1 again because that's where we put it. Y bars, function y1. And then this is x equals 1.5. This is a tested skill that you know how to take the numeric derivative with a calculator. So we have -0.999, or it looks like you could round that to -1, is -1, and then we're going to interpret this, do we have units of time? I'm not reading units of time in here. generally do these in seconds, but I'm going to say seconds. -1, you accurate 3 decimals, so 1 would be accurate 3 decimals, rounded or chopped. So -1, given any other units? We're not giving any units, so I'm just going to leave it at that. Position of the particle at time t is x of t, and its position at time t equals 1, x of 1 equals -3. Find the position of the particle at time t equals 4. Show the setup for your calculations. So this one, the ending position is going to be the initial position. So we're going to say x of 4 is what we're looking for. That's going to be equal to x of 1 plus the integral from 1 to 4 of v of t dt. And that's going to give us, this is the accumulated change in position plus the initial position. So that's going to be x of 1 is -3, and then we're going to integrate v of t. Let me make sure I got the right thing in there. I do. So I'm going to second quit. I'm going to do math. Function integrate again. And this is going to be from 1 to 4. And this is going to be y1 because it's v of t. That's what we have entered in there with respect to x, because that's the variable I used in the calculator. And I'm going to do plus the initial position of -3. And so that's -2.802 or 803, either one would work. That's the position at time t equals 4. Find the total distance traveled by the particle over the integral from 1 to 4. All right, the change in position is given by the integral from 1 to 4 of v of t dt. But if you want the total distance traveled, that means you count the distance to the right as positive and then count the distance to the left also as separate distance. We're going to integrate the absolute value of v of t dt. And that's going to be second. Yeah, function integrate. This time we're going to do 1 to 4. This time we're going to do absolute values, or math, num, absolute value. And then we're going to do y1 with respect to x, because that's the variable we use in the calculator. And it's figuring 0.958 is the total distance traveled by the particle over the interval from 1 to 4. And that's question 2. That was pretty easy. Like I said, if they do poorly on that one, I'll be shocked. I don't understand why that would have been very hard. Whoops.